Here is a world map. Have you ever used the concept of latitudes and longitudes to find your city's location on a map? At the end of the lesson, you should be able to explore the idea of placement or location of an object with frame of reference. Analyze the concept of Cartesian plane. Locate the position of an object or point on a Cartesian plane. Plot a point in a two-dimensional Cartesian plane. Joe and Peter decide to watch a play in an auditorium. Peter has the tickets, but he's getting late for the show. So he tells Joe to go inside the theater and seats number are 12 and 13. Now, Joe goes inside the auditorium and sees that there are rows labeled with alphabets A, B up to Z, and the seats are numbered 1 to 20 in each row. He remembers that his seat number is 12. With the information he has, can he locate his seat in the auditorium? He can't, because every row has a seat numbered 12. What other information does Joe need to know to locate his seat? He needs to know the row number. By this time, Peter comes in and they check the ticket. Their seats are D12 and D13. With this information, they are easily able to locate their seats. Why do you think they were able to locate their places now? This was because they had two pieces of information, the row in which the seat is located and the seat number. So there was no ambiguity. Now, let us look at another situation where you have to locate positions of a location on the map of Bangalore city. From this map, can you describe the location of Jayanagar Super Bazaar to your friend? Yes, you would tell your friend it on 16th Main Road and at the juncture where it meets the 36th Crossroad. So, again, we use two sets of information to locate the place. Let us take another example. Let us draw a star on a plain sheet of paper. Perhaps we try it in this way. The position of the star is in the upper half of the paper. It is on the left edge of the paper, or it is very near the left-hand upper corner of the sheet. Do any of these statements fix the position of the star precisely? Now, we make a grid on the paper and place the star in the same position where it was earlier on the plain sheet of paper. Now, how would you describe the position of the star? You would now say it is in the second row, fifth column. So, we took two independent sets of information to find the position of a point. What do you observe in these cases? We observe that the position of any object lying in a plane can be represented with the help of two perpendicular lines. These situations require the knowledge of coordinates and the methods of plotting in the grid system. This idea gave rise to a very important branch of mathematics called the coordinate geometry. Let us recall the number line that we have studied in earlier classes. On the number line, distances from a fixed point are marked in equal units positively in one direction and negatively in the other. The point from which the distances are marked is called the origin. The point in the positive direction at a distance r from origin represents the number r. Similarly, the point in the negative direction at a distance r from origin represents the number minus r. Take two number lines. Label them as xx' and yy'. Place one number line xx' horizontal and place the other yy' as vertical. Combine both the lines in such a way that the two lines cross each other at their zeros or origins. The horizontal line xx' is called the x-axis and the vertical line yy' is called the y-axis. The point where xx dash and yy dash cross is called the origin and is denoted by O. OX and OY are called positive directions of x-axis and y-axis. Similarly, OX dash and OY dash are called the negative directions of the x-axis and y-axis respectively. The axes divide the plane into 4 parts which are called quadrants. The quadrants are numbered 1, 2, 3 and 4 anticlockwise from OX. The Cartesian plane or the coordinate plane or the xy plane consists of axes called the coordinate axis, and the system used for describe the position of a point in a plane is known as Cartesian system. P and Q are 2 points on the coordinate system. At what distances are the points P and Q from the axis? To find this, from point P, draw perpendiculars PM on the x-axis and PN on the y-axis. Similarly, from point Q, draw perpendiculars QR on x-axis and QS on y-axis. What do you observe? We find that for point P, the perpendicular distance of the point P from y-axis measured on the positive direction of x-axis is Pn, that is equal to OM, which is equal to 4 units. Similarly, the perpendicular distance of the point P from the x-axis measured along the positive direction of the y-axis is Pm is equal to On, which is equal to 3 units. For point Q, the perpendicular distance of the point Q from the y-axis measured on the negative direction of x-axis is OR is equal to SQ, that is equal to 6 units. Similarly, the perpendicular distance of the point Q from the x-axis measured along the negative direction of the y-axis is OS is equal to RQ, which is equal to 2 units. How do you write the coordinates of these points to describe their location? We write the coordinates of a point using the following conventions. The x-coordinate of a point is its perpendicular distance from the y-axis measured along the x-axis, positive along positive direction of x-axis and negative along the negative direction of x-axis. It is also called the abscissa. The y-coordinate of a point is its perpendicular distance from the x-axis measured along the y-axis, positive along a positive direction of y-axis and negative along the negative direction of y-axis. It is also the ordinate. In stating the coordinates of a point in the coordinate plane, the x-coordinate comes first and then the y-coordinate. Place the coordinates in the brackets. Each coordinate describes a point uniquely. Here, the coordinates of P are 4 and 3, and the coordinates of Q are -6 and -2. If a point R lies on the x-axis, then what will be its coordinates? Since every point on the x-axis has no distance from the x-axis, therefore, the y-coordinates of every point lying on the x-axis is always 0. Thus, the coordinates of any point on the x-axis are of the form x, 0, where x is the distance of the point from the y-axis. If a point S lies on the y-axis, then what will be its coordinates? Every point on the y-axis has no distance from the y-axis. Therefore, the x-coordinates of every point lying on the y-axis is always 0. So, the coordinates of any point on the y-axis are of the form 0, y, where y is the distance of the point from the x-axis. What are the coordinates of the origin O? The origin has 0 distance from both the axes, so that its abscissa and ordinate are both 0. Therefore, the ordinates of the origin are 0, 0. Here are some of the coordinates of the given points in the coordinate system. What do you observe? In the coordinate system, point K lies in the first quadrant and both its x and y coordinates are positive. Point L lies in the second quadrant. Its x coordinate is negative and y coordinate is positive. Point M lies in the third quadrant. Both the x and y coordinate are negative. Point N lies in the fourth quadrant. Its x coordinate is positive and y coordinate are negative. What relationship do you observe between the signs of the coordinates of a point and the quadrant of a point in which it lies? If a point is in the first quadrant, then the point will be in the form of plus, plus, since the first quadrant is enclosed by the positive x-axis and the positive y-axis. If the point is in the second quadrant, then the point will be in the form of minus, plus, since the second quadrant is enclosed by the negative x-axis and the positive y-axis. If a point is in the third quadrant, then the point will be in the form of minus, since the third quadrant is enclosed by the negative x-axis and the negative y-axis. If a point is in the fourth quadrant, then the point will be in the form of plus, minus, since the fourth quadrant is enclosed by the positive x-axis and the negative y-axis. Peter and Sam are in an amusement park. They have the map of the park with them. They first decide to go to the Ferris wheel F. If they take the location where they stand as the origin, they have to go 2 yards to the east and 5 yards to the north. Let us draw the coordinate axis. Let us choose 1 centimeter is equal to 1 unit for x-axis and the same 1 centimeter is equal to 1 unit for the y-axis. Let us plot the point F2, 5 in the coordinate axis. If you look at the coordinates of the point 2, 5, in which quadrant will it lie? Yes, it will lie in the first quadrant as both the coordinates x and y are positive. Let us now locate the point F2, 5. We know that the point is represented by x, y. What is the x and y coordinates of point F? The x coordinate is 2 and y coordinate is 5. Let us start with the origin 0, 0. To locate point 2, 5, we first look at x coordinate. Since the x coordinate is 2, so count 2 units on the positive x-axis and mark the point as A. We then look at the y coordinate of the point, which is 5. Now move 5 units in the positive direction of the y-axis and mark the point as F, which is the Ferris wheel. The distance of F from the y-axis is 2 units and from the x-axis are 5 units. Hence, F is the position of the point. They go back to the origin and decide to go to the water slide W, which is 3 yards to the west and 2 yards to the north. Hence, the coordinates are -3, 2. If you look at the coordinates of the point -3, 2, in which quadrant will it lie? Yes, it will lie in the second quadrant. To locate the point, let us locate 0, 0. Let us look at the coordinates. The x-coordinate is -3. Let us move -3 on the negative x-axis and mark the point as B. Now, look at the y-coordinates. It is 2. From point B, move 2 units in the positive y direction. Now, mark W, -3, 2 in the second quadrant. Let us now locate giant coaster, which is at 5, 2. Since both x-coordinate and y-coordinate are positive, it lies in the first quadrant. When we look at the location of the giant coaster G, 5, 2, it looks similar to the location of the Ferris wheel F2, 5. Are the giant coaster and Ferris wheel located in the same place? No. When we observe the x and y coordinates of the 2 points, we see that though they have the same numbers, they are in different locations. The coordinate pair x, y is not equal to y, x if x is not equal to y. As the coordinates of x and y are interchanged, the position of y, x will differ from the position of x, y. Sam and Peter are at different rides in the same park. Sam calls Peter and asks him where he is. Peter replies he is in the log ride, which is located at 4, 4. Sam is at the SkyTrain 4, 1. He starts walking to meet Peter. In which direction and how many units will he walk to reach Peter? He will walk 3 units in the positive direction. Then he moves 4, 1 plus 0, 3, that is equal to 4, 4. Are they both at the same point now? Yes. When we look at the coordinates, we see that both Sam and Peter are at 4, 4. The coordinates of x and y are the same, hence they are in the same point. The coordinate pair x, y is equal to y, x if x is equal to y. As x is equal to y, the coordinates of x and y are same. They represent the same point. Rita throws 2 dice simultaneously and gets the number 4 and number 3 over the red and green dice respectively. How do you locate this move in the coordinate plane? The coordinates of the point 4, 3 tells us the distance of this point from the y-axis along the positive x-axis is 4 units and the distance of the point from the x-axis along the positive y-axis is 3 units. Starting from origin O, we count 4 units on the positive x-axis and mark the corresponding point as A. Now, starting from A, we move in the positive direction of the y-axis and count 3 units and mark the corresponding point as P. What do you observe? We see that the distance of P from the y-axis is 4 units and from the x-axis is 3 units. Hence, P4, 3 is the location of point in first quadrant because both the coordinates of P are positive. Now it is Ronnie's turn. He throws both the dice simultaneously and gets the number -3 and number -1 over the red and green dice. How do you locate this move in the coordinate plane? Now, starting from origin O, we count 3 units on the negative x-axis and mark the corresponding points as B. Now, starting from B, we move in the negative direction of the x-axis and count 1 unit and mark the corresponding point as R. In which quadrant will the point R -3, -1 lie? We see that the point R is at a distance of 3 units from the negative y-axis and 1 unit from the negative x-axis. Hence, the point R is the location of point in third quadrant because both the coordinates of R are negative. Now, it is Rita's turn. She gets the number 2, -3. Can you help Rita plot this move? Yes. Starting from the current position A, 4, 3, add the respective coordinates of 2, -3. So, its new position will be at Q, 6, 0. Since its y-coordinate is 0, this is a point on the x-axis and it is at a distance of 6 units from the y-axis. It's Ronnie's turn again. He gets the numbers 3, 5 on the dice. What will be the new position of Ronnie's move? Initial position of Ronnie was at -3, -1. So, the new position of the move will be at 0, 6. Since the x-coordinate is 0, the point S 0, 6 will lie on the positive y-axis and at a distance 6 units from x-axis. So, Rita and Ronnie are at positions Q 6, 0 and S 0, 6. Are the new positions the same? No, the 2 points are at 2 different locations. Point Q is on the y-axis and the point S is on x-axis. From this, we can conclude that if we interchange the coordinates x and y, the positions of y, x will differ from the position x, y. That is, if x is not equal to y, then the position of x, y in the Cartesian plane is different from the position y, x. So, the order of x and y is important in x, y. That is, the ordered pair x, y is not equal to the ordered pair y, x if x is not equal to y. Rita throws the dice and gets -6, 6 on the red and green dice respectively. So, new positions will be at 0, 6. This is the same as Ronnie's position. What do you conclude from this? Here, the ordered pair x, y is equal to ordered pair y, x. That is, x is equal to y. Thus, x, y is equal to y, x if x is equal to y. René Descartes, the great French mathematician of the 17th century, solved the problem of describing the position of a point in a plane. It is said that he came to this conclusion of plotting by watching a spider or a fly move along the ceiling. He looked at that movement as an enemy battalion on a battlefield, and he wondered how he could send information to another commander as to the position and the movement of this battalion. Although latitude and longitude were well known, the plotting of a series of points that solved an equation was a big breakthrough. In honor of Descartes, the system used for describing the position of a point in a plane is known as the Cartesian system. Now, let us study some of the applications of coordinate geometry in real life. The concept of coordinate geometry is widely used by architects to design houses. It is used in graphic designing software to manipulate images. We often use it to navigate a city or to locate objects in a grid. We use coordinates of latitude and longitude to locate a place or a country on a globe. Astronomers and amateurs use sky coordinates to locate objects of interest. Users of maps may use the coordinates provided on the edge to find a place of interest.